Hi students, welcome to Future Doctor NEET Academy for the live stream session in physics. This is a crash course in physics. Chapter 9, Ray Optics and Optical Instruments is the topic we are dealing. Already last session we have started this one and some more parts are pending in this chapter that we will continue, and then we will move to next chapter, chapter 10. Actually, the topic is ray optics and optical instruments. In there, some of the properties, that is reflection, we have studied. Reflection through a mirror, is it so? And reflection through a plane mirror, reflection through a curved mirror in the sense convex mirror, concave mirror, that things we have discussed. And refraction through lens we have discussed as a convex lens, concave lens, focal length of the convex lens, focal length of the concave lens, and then power of the lens and defect of the eye, that is a short sight, long sight, astigmatism, that things and all we have discussed. Now the topic is refraction through prism. What is refraction? That already we have discussed. Refraction is the change in direction of the light ray when it passes from one medium to other medium. That is the refraction. Refraction is the change in direction of the light ray when it passes from one transparent medium to other transparent medium. And when light passes through a prism, then when a ray of monochromatic light, what is monochromatic? Can you say what is monochromatic? Mono means single. Chromatic, chrome. Chrome means what? In biology you may study. Chrome. Chromatic means color. So general speaking, monochromatic means single color. In physics, color is due to wavelength. Okay. So what is monochromatic light? Means a light which has single wavelength or definite wavelength. That is only monochromatic. Okay. Monochromatic means it's a light source having single wavelength or definite wavelength. For example, violet color has one definite wavelength, that is 4000 Armstrong. Okay. And green color some 5000 Armstrong. Yellow color 6000 Armstrong. And red color 6800 Armstrong. Red color 6800 Armstrong. That is due to the change in wavelength only different colors. Okay. In visible light we are discussing. So what is monochromatic? Monochromatic is a light source having single wavelength or single color. Okay. When a ray of monochromatic light is refracted by a prism, the deviation, that is denoted by a symbol delta, produced by the prism is del equal to I plus E minus A. Del equal to I plus E minus A. What is I? I is the angle of incidence. E, angle of emergence. E is the angle of emergence, and A, angle of the prism. Angle of the prism. And angle of deviation. Actually, for a prism, two things needed. One is A, angle of prism, another one, angle of deviation. Okay. Actually, spectrometer is a one device or instrument to determine angle of prism and angle of deviation. I think this you would have studied in your 12th standard, spectrometer. Using spectrometer, you can find the angle of prism A, that is 60 degree. And angle of deviation, that may be a delta or D. Delta will be angle of deviation, and delta M or capital D, that will be angle of minimum deviation. And angle of deviation delta M is minimum when ray passes symmetrically through the prism. For that only in spectrometer we will do some adjustment. Okay, that is a collimator will be adjusted and light will be falls on a prism, and prism position should be adjusted such that whatever rotation of the prism table in a prism, light will move in a same direction. Left or right, it will be moving same direction. That is the angle of minimum deviation. Then after finding that Angle of deviation becomes angle of minimum deviation, that may be used as delta M, or in our lab in spectrometer we will use capital D. Capital D is the angle of minimum deviation. Now formula is mu equal to sin A plus delta M by 2 by sin A by 2, or mu equal to sin A plus D by 2 by sin A by 2. This is the formula, and A is the angle of prism. That is a separate experiment to determine the angle of prism value. Value will be 60 degree. 60 degree is the angle of prism that we will find approximately in spectrometer 59 degree something or 60 degree something you will get. And angle of minimum deviation approximately 38 degree or 39 degree we will get. And on substituting this, refractive index of a glass 1.5. Yesterday itself we found. Is it so? Refractive index of glass mu equal to 1.5. So probably some different colors we will get for minimum deviation, starting from violet to red, and whatever color mu will be constant as 1.523, 1.515, 1.562. Like that, average you will get as mu equal to 1.5. Okay, so mu equal to 1.5 is the refractive index of a glass prism. Okay. Next, dispersion of white light through prism. Previously is refraction of light through a prism. Now dispersion of white light through prism. What is dispersion? Dispersion is the phenomenon of splitting of a ray of light, white light, into its constituent colors. That is different colors. See, already I said different wavelength only it appears different colors. So different wavelength for our eye, different colors. This is only for visible light only. And the splitting of white light into several colors is called dispersion, and the band of colors from violet to red, that is called spectrum, visible spectrum. Previous class we have discussed electromagnetic spectrum, starting from gamma rays to radio rays, radio waves. Now this is visible spectrum is VIBGYOR. What is VIBGYOR? V refers violet, I indigo, B blue, G green, Y yellow, O orange, or red. That is VIBGYOR. And see, white light is falls on the prism, and some adjustment is needed in spectrometer, then we will get different colors. By adjusting the telescope angle, we will get violet to red. That angle can be noted, then from that you can find or you can determine the refractive index of the different colors. And here see, mu V is greater than mu R, and therefore refractive index angle of refraction is for red is greater than violet. So the colors are refracted at different angles and hence get separated. Okay. Optical instruments. Yesterday itself I said first natural optical instrument is human eye. See, human eye is the most familiar and complicated natural optical instrument that is only provided by nature to living things, living beings. In this device, light enters through a curved front surface, just like light enters through a lens called cornea, passes through the pupil and central hole in the iris. The light is focused by the eye lens on the retina. The retina senses light intensity and color and transmit the electrical signal via optical nerves to the brain. And brain finally processes the information. Brain only processes the information and identified this is the student, this is the staff, this is a boy, this is girl, this is a man, this is a human being, this is the animal, this is the object that can be sensed by brain. Another optical instrument is microscope. A simple microscope is a short focal length convex lens. That only we are calling as a magnifying lens. Magnifying lens. Simple microscope is a short focal length convex lens, that is nothing but small lens, magnifying lens. And the magnifying power of a simple microscope is M equal to 1 plus D by F. M is a magnifying power, F is the, what is F? F is the focal length. What is D? D is the what distance? least distance of distinct vision. That is only D. What is D? D is the least distance of distinct vision. That is the minimum distance in which human eye can perceive. That is called least distance. Okay. For example, for our human eye, approximate least distance of distinct vision is 25 centimeter. 25 centimeter. Okay. D, 25 centimeter is the least distance of distinct vision for human eye for adult. For children, it will be less than that. That's why parent and all will be advised, don't keep your books closer to your eyes. Keep some distance. Okay. That minimum distance the human eye can perceive is 25 centimeter. So we have to keep whatever books or whatever to read, it should be above 25 centimeter. Below or less than 25 centimeter means our least distance of distinct vision, that adjustment of the focal length, that only we are calling power of accommodation, that will be disturbed. That also leads to defects in eyes. Okay. Then the magnifying power M of a compound microscope is M equal to MO into ME. That is objective magnifying power of objective, and ME is the magnifying power of eyepiece, equal to V by U into 1 plus D by FE. Okay. MO is the magnifying power of objective lens, because actually compound microscope means contains two lenses. Objective lens, that is nearer to object, is objective lens, and nearer to our eye, that is called eyepiece. Okay. The two lenses having different magnifying power based on the difference in focal length. So MO into ME, and MO is V by U, ME is 1 plus D by FE. Here MO and ME is the linear magnifying of the objective and eye lens. Telescope. What is the difference between microscope and telescope?
With telescope we can see long distance object.
Distant object, good. And microscope?
Near distance object.
Near distant object. What is the meaning of near distant? Near distant. Okay, very good. Anyhow, okay, good. What is microscope? Microscope, what we are saying? Microorganism, small organism, small particles. Okay. And even lens, normal magnifying lens itself, small letters and all can be viewed by magnifying lens. That only we said as a simple microscope in previous topic. Okay. So that is a magnifying lens. So it magnifies the image. So the letters or whatever can be magnified. That is a magnifying lens. And magnifying lens may be 100 times or 10 times it will be magnified. And compound microscope. This compound microscope may magnify 1000 times. That is a compound microscope. And microscope is used to see microorganisms or small organisms. So small particle can be magnified as a bigger object. That is microscope. Telescope, tele means distance. Distant object can be appear as a nearer one. That is telescope. Magnifying power of refracting telescope is M equal to FO by FE. And here L equal to FO minus FE. L is the length of the telescope. Okay. So length of the telescope also decides the magnifying power. For the final image is formed at the least distance of distinct vision, the magnifying power is M equal to FO by FE into 1 plus FE by D. And resolving power of a telescope, that is theta equal to 1.22 lambda by D. In 2 or 3 days back, in problem solving session, we use this formula. Resolving power of a telescope, resolving power of a microscope. 2 problems we have discussed in this. Theta equal to 1.22 lambda by D. That is resolving power we want to find. Lambda and D is given. And theta and lambda is given. We want to find a D. What is D? D is the diameter of the objective of the telescope. D is the diameter of objective lens of the telescope. And lambda, wavelength of the light. Theta, angle subtended by the point object at the objective. That only we are calling resolving power. What is resolving power? Resolving power means two closer object appears as a separable one. That is the resolving power. For example, In night you are looking through the stars in your sky. Okay. And stars, suppose one star appears there. You are looking one star. And if you use telescope, highly resolving power telescope, it may contain some 10 number of stars or 20 number of stars. So that is closer object appear as a separable one, that is called resolving power. Okay. Actually, that I said no 10 number of stars. 10 number of stars may be having some thousands of kilometer distance. But for our vision, it may appear as closer one as a single star. But that is not a single star, 10 number of stars, 20 number of stars. So we can see as a 10 number of stars or 20 number of stars using highly resolving power of the telescope. That is only resolving power. Resolving power means closer object appear as a separable one, separatable one. That is the resolving power. Magnifying power, smaller object appears as a magnified one, bigger one. Celestial telescope. That is a rays from a distant objective, convex lens, and the point will be focused at a particular point, focal point, and magnifying eyepiece. This is only objective lens and magnifying eyepiece. Eyepiece lens and eyes is a normal telescope. Telescope, ray optics. And compound microscope, here itself two lenses will be used. One will be short focal length and a point to focus. Then magnifying eyepiece. Okay. So just this simple principle only appeared for telescope and microscope. In telescope, distant object appear as a nearer one. In microscope, smaller object appear as a magnified one. That is a microscope. Both are optical instruments. Already we discussed resolving power of a microscope is 1 by delta D, that is 2 in terms of refractive index means 2 mu sin theta by lambda. Resolving power depends upon wavelength of light. Okay, wavelength of light used. And refractive index of the medium between the object and the objective. Off angle of cone of light from one of the objects. And resolving power of a telescope, that is 1 by d theta equal to a by 1.22 lambda. And a is the diameter of the objective. Lambda is the wavelength of the light used. So for both microscope and telescope, resolving power depends upon wavelength of the light used. Okay, noted, no? Right. So this chapter, okay. So both resolving power of microscope as well as telescope depends on lambda, wavelength of the light. Okay, thank you. We'll move to next chapter. Next chapter is wave optics. Wave optics. Already we have discussed the electromagnetic waves. What is electromagnetic wave? That is variation in both electric and magnetic field occurs simultaneously. That is electric field varied along y-axis as per the diagram, and magnetic field varied along z-axis, and both will be occurs simultaneously. That is both will reach as maximum at same time, reach as zero same time, like that. So its phase difference is 0. Both are in same phase that we have discussed. And therefore they attain the maximum and minimum at same place at same time. Direction of electric and magnetic fields are mutually perpendicular to each other and perpendicular to direction of motion or propagation of wave. The propagation of wave is along x-axis, and direction of vibration of electric field is along y-axis, and direction of vibration of magnetic field is along z-axis. All the three are mutually perpendicular. And the speed of electromagnetic wave depends entirely on the electric and magnetic properties of the medium. Therefore, C equal to 1 by mu naught epsilon naught. And wave is propagating along x-axis with speed C equal to 1 by square root of mu naught epsilon naught. That already we have discussed. That is, velocity of wave in a vacuum is C equal to 1 by square root of mu naught epsilon naught. Mu naught is the permeability of a free space or vacuum, and epsilon naught is the permittivity of a free space or vacuum. This is the velocity of the electromagnetic wave in the vacuum or air. And already we have discussed that both electric and magnetic fields are important, but electric field is more significant than magnetic field. So, electric field we are calling as a light vector. And different theories are put forth to explain about the theories of light. Okay, that is Newton's corpuscular theory, wave theory, electromagnetic theory, like that. One theory explain one properties. Okay. For example, one theory explain light undergoes reflection, refraction. Other theory explain light undergoes photoelectric effect, like that one theory. And first theory is corpuscular theory, was proposed by Sir Isaac Newton. According to him, light consists of extremely small, invisible elastic particles traveling in vacuum with a speed of 3 into 10 power 8 meter per second. Light consists of extremely small particles, invisible elastic particles traveling in vacuum with a speed of 3 into 10 power 8 meter per second. This theory is able to explain reflection and refraction. It explains about the light that undergoes reflection, also refraction, but could not explain interference. That also important property. Diffraction, not able to explain. Polarization, not explained by this theory. Photoelectric effect, not explained. Compton effect, these and all not explained by this theory. Also, it failed to explain why light travels faster in rarer medium than in denser medium. What is rarer medium and denser medium? Can you say? What is rarer medium, denser medium? For example, compare air and water. Air and water, both are transparent, is it so? Air is also transparent, light can pass through, and water also transparent. And compare air and water, which is rarer medium, which is denser medium? Yes, air is rarer medium, water is a denser medium. It means less density. And compare water and glass, which is rarer, which is denser? Water is a rarer, and glass is a denser medium. And see, that is in air 3 into 10 power 8, this is only I mentioned. In air, velocity of light is 3 into 10 power 8 meter per second. But in glass, 2 into 10 power 8 meter per second. This was failed to explain by corpuscular theory. Corpuscular theory not able to explain why light travels faster in rarer medium. Light travels faster in air than in glass. Not explained by this theory. So this is one of the drawback of this theory. Okay. Next theory, wave theory, proposed by Eugene. Light travels in a medium in form of wave front, where what is wave front means? Wave front is the locus of all the particles vibrating in same phase. What is wave front? Wave front is the locus of all the particles vibrating in same phase. And when source of light is a point source, the wave front is spherical. Wave front is the locus of all the particles. Locus means moving circle, moving wave, that is called locus. And when a source of light is a point source, wave front is spherical. And amplitude is inversely proportional to distance. That is, A is inversely proportional to 1 by x. And amplitude is inversely proportional to distance means that intensity is proportional to A square. I is intensely proportional to A square, therefore I is inversely proportional to x square. Okay. Intensity is proportional to square of the amplitude, and A is inversely proportional to x. Therefore, I is inversely proportional to square of the distance. And when a source of light is linear, the wave front is cylindrical. For point to source, it is a spherical shape, and for linear straight line means cylindrical shape. Then, for this also amplitude is inversely proportional to x only, but square root of x. Okay, amplitude is inversely proportional to square root of x. And intensity is proportional to amplitude square, therefore is proportional to x. Intensity is inversely proportional to distance. Okay, noted, no? Next theory, Maxwell electromagnetic theory. Here some more top points are there. At very large distance from the source, a portion of spherical or cylindrical wavefront appears to be plane. That only we are calling plane wavefront. And a wavefront travels parallel to itself and perpendicular to the rays. And wavefront always travels in forward direction of the medium, no backward, forward direction only. In an anisotropic medium, what is anisotropic? Iso means same, tropic means direction. Same direction. Anisotropic means different direction. That is, some of the properties are same in a direction with direction, that is isotropic. Some of the properties are different with direction. For example, some properties, if you send light along x-axis, it will be behavior will be one, and other axis different. That is only anisotropic. For anisotropic medium, a point source gives rise to an elliptical wavefront. And Huygens wave theory could able to explain reflection, refraction, interference and diffraction, but failed to explain polarization. And so according to him, light waves to be longitudinal. So it also failed to explain, that's why polarization. And it also could not explain backward propagation of light. And photoelectric effect, Compton effect, Raman effect, these are all not explained by this theory. Next is electromagnetic theory proposed by Maxwell. Electromagnetic waves or transverse waves. What is transverse wave? The particles of the medium vibrates perpendicular to the direction of propagation of wave. That is called transverse waves. Longitudinal waves, the particles of the medium vibrates parallel to the direction of propagation of wave, that is longitudinal wave. And electromagnetic waves are transverse in nature and which require no material medium for propagation, and they can travel through even vacuum. Due to transverse nature, light undergoes polarization. What is polarization? Polarization is the phenomenon of restriction of vibration in a particular plane. That is called polarization. And in this wave, electric field vector E and magnetic field vector B vibrate in same phase along mutually perpendicular direction. This was explained by this theory only. And E and B are perpendicular and perpendicular to propagation of light C. And from that only C equal to E by B, or C equal to E naught by B naught, that is equal to 3 into 10 power 8 meter per second. And velocity of electromagnetic waves in vacuum, C equal to 1 by square root of mu naught epsilon naught. This was given by this theory only. That is, what is C? C is the velocity of the electromagnetic wave in vacuum. Mu naught. What is mu naught? Mu naught is the permeability, that is magnetic permeability of the medium or absolute permeability. Epsilon naught is the permittivity of a free space or absolute permittivity. And velocity of electromagnetic waves in medium is less than that of light. That is V equal to C by square root of mu or epsilon r. Mu r is the relative permeability and epsilon r is the relative permittivity. V equal to C by square root of mu or epsilon r. Mu r is the relative permeability and epsilon r is the relative permittivity. And the velocity of electromagnetic waves in a medium depend upon the electric and magnetic properties of the medium. And it explains the phenomenon of reflection, refraction, interference, diffraction and also polarization, but failed to explain photoelectric effect, Compton effect and Raman effect. This phenomenon, this property not able to explain by this Maxwell electromagnetic theory. Next theory, Planck's quantum theory. Quantum theory proposed by Max Planck. Light consists of packets of energy, that is discrete bundles of packets of energy, that is called quanta or photons. According to Max Planck, light is made up of discrete bundles of packets of energy called quanta or photons. The photons are emitted discretely and not continuous. What is discrete means? It's not a continuous. That is a discrete. How is that means? E equal to nh nu. What is n? N is the integer, that is number of photon. N equal to 1h nu, n equal to 2h nu, n equal to 3h nu, like that. That's why we are calling it is a discrete bundles of packets of energy. And energy of the single photon, n equal to 1, that is h into nu. Nu equal to c by lambda we know, so h c by lambda. H c by lambda, and velocity of photon is equal to that of light. Velocity of photon is equal to that of light. That only we are calling light. Light, actually light in the form of particle is photon. Residual mass of photon is 0. When when photon is at rest, then its mass will be 0. And effective mass of photon, effective mass means mass of the photon increases with velocity. When speed increases, its mass also increases. That is only effective mass. Effective mass is m equal to hu by c square equal to h by c into lambda, and equal to energy by c square, actually derived from E equal to mc square. E equal to mc square, then m equal to E by c square. E equal to h nu, that only given as h nu by c square. Okay, E equal to h nu as h nu by c square, and nu by c equal to lambda. So h by c lambda, and h nu is energy, energy by c square, h nu by c square, energy by c square. Spin of the photon is h cross equal to h by 2 pi. What is h cross means? H cross is the nothing but quantity h divided by 2 pi. H is a Planck's constant. And momentum of photon P equal to m into c. M is a mass, c is a velocity. Already we know momentum is nothing but product of mass and velocity. Mass is m and c is the velocity of light. And this is also equal to h by lambda. According to de Broglie, h by lambda, that is equal to h nu by c. And h nu is energy, so energy by c. Therefore, momentum P equal to energy by c. And photons are electrically neutral. Okay, neutral means no charge. Photons are not having no negative, no positive. It is a neutral charge. And quantum theory could explain photoelectric effect, Compton effect, and Raman effect. But it failed to explain interference, diffraction, and polarization. Okay, it failed to explain interference, diffraction, polarization, but this was able to explain by previous theory. Next is de Broglie dual theory. What is a dual meaning? D-U-A-L, dual, double role. In cinema, hero or heroine acting double role, twin role, we are saying that is the dual role. Okay, dual means double. That is, light behaves both as corpuscle and as a wave. Corpuscle means particle. Light behaves as a particle, also behaves as a wave. Corpuscular and wave aspects are like the two faces of a coin. That is, which can never separated, which can never joined also. That is, if you are looking one side of the coin, other side we can't see. Just like that, if you are saying if it is a particle, you should forget it is a wave. If you see if it is a wave, you should forget particle. In some phenomena, it behaves like transverse wave. That is, interference, diffraction, and polarization proves that light is a wave, not a particle. Suppose light is a wave means it's proved by experiment, interference, diffraction and polarization. And suppose particle nature means we should follow photoelectric effect, Compton effect and Raman effect. So this experiment, photoelectric effect, Compton effect, Raman effect, proves light is a particle nature. So this dual theory explains all the phenomena and effects of light. Okay. As wave, its energy is h nu equal to hc by lambda. As particle, its momentum is h by lambda. That is only de-Broglie wave. And G.P. Thomson and Davidson and Germer experimentally verified this theory. G.P. Thomson and Davidson Germer only proved this theory, de-Broglie theory. And de-Broglie wave equation is lambda equal to h by p equal to h by mv. Lambda equal to h by p equal to h by mv. Here h is a Planck's constant. And lambda is only de-Broglie wave, is nothing but h by p. What is p? P is the momentum. And as we have discussed, wavefront is a moving disturbance, moving point due to propagation of light, and this is a wavefront, spherical wavefront, that is a moving point. For spherical wavefront, it's moving like this. For point to source, it looks like a spherical wavefront, and for plane wave, it looks like a cylindrical wavefront. And for plane wavefront, it looks like this. That we are calling, for straight line like this, it looks like a plane wavefront. Interference of the wave. What is interference? It is a phenomenon of superposition of two waves having same frequency and same amplitude. That is called interference. And during interference, there may be a increased intensity at some other point and decreased intensity at some other point. For example, E1 is the intensity of the one wave, and E2 is the intensity of other wave as two color, red and blue or violet. Then total intensity is E1 plus E2, E equal to E1 plus E2. That only we are calling constructive interference. What is constructive interference? Increased intensity at a point is called constructive interference. And decrease in intensity is called decreasing destructive interference, E equal to E1 minus E2. Then because of constructive interference, we are getting bright band, bright fringes or bright spot. And due to destructive interference, dark band. So alternative bright and dark band will be appears on the screen. That only interference. Interference there, alternative bright and dark bands. Comparison of intensity of maxima and minima. That is, I max is equal to A plus B whole square. I minimum is A minus B whole square. So I max by I minimum equal to A plus B whole square by A minus B whole square. And R equal to A by B, if you substitute like this, then I max by I minimum equal to R plus 1 whole square by R minus 1 whole square. Here R is the ratio of the amplitude. And relation between intensity, amplitude and width of the slit. Intensity and amplitude of the wave and width of the slit. Already we know intensity is proportional to A square and A is proportional to square root of width. Therefore, I1 by I2 equal to A1 square by A2 square equal to W1 by W2. I1 by I2 equal to A1 square by A2 square equal to W1 by W2. W1 by W2 is the width of the slit. Here I1, I2 intensity, A1, A2 amplitudes. So this is the comparison of intensities of maxima and minima. Maxima is increased intensity, that is called constructive interference. Minima may be decrease in intensity, destructive interference. Noted? Noted? So question in theory question may be asked, compare with the intensity with amplitude or width. Young's double slit experiment. There will be a slit, source and slit will be there, and double slit will be there, single slit, double slit, and here is the interference pattern. I said no, increase intensity and decrease intensity. Increase intensity is denoted by a color, blue color. Decrease intensity, black color, dark color. As bright and dark bands we will say. Bright and dark bands. And here S is a single source and S1, S2 are the two coherent sources. Actually, main important condition for interference is sources must be coherent. Coherent means two sources should produce same frequency, same wavelength, same amplitude and start with same phase difference. That is called coherent sources. Here S1 and S2 are the coherent sources. It is difficult to produce different source as a coherent source. So from single source is possible to obtain two coherent sources. So that only from single slit we are getting double slit as double coherent sources. And what is small d? Small d is the distance between two sources, coherent sources, and capital D is the distance between the coherent sources and the screen, image obtained. Okay, so based on this we will work out problems. What is D? D is the distance between two coherent sources and capital D is the distance between coherent sources and the screen. And delta is the path difference. Path difference equal to YD by D. And position for bright fringes. For a bright fringe, delta equal to YD by D equal to N lambda. N lambda, if the path difference is equal to integral multiple of wavelength as N lambda, then that is the condition for bright bands or bright fringes. In problems, it will be asked like this. That is, what is the position of the bright fringes or condition for bright fringe? If the path difference is equal to integral multiple of wavelength, that is N lambda, that is the condition for bright band or bright fringes. And if the path difference is odd integral multiple of wavelength, that is 2n plus 1 lambda by 2, that is for condition for dark band. And if you substitute n equal to 0, n equal to 1, n equal to 2, we will get this one. Same way if you substitute n equal to 0, 1, 2, 3, we will get this. Okay. So for condition for bright fringe, path difference is equal to integral multiple of wavelength, and condition for dark fringe, odd integral multiple of wavelength. Odd integral multiple of wavelength means 2n plus 1 by 2 of lambda. And here n value 0, 1, 2, 3. And expression for fringe width. Fringe width or bandwidth. Its other name bandwidth or fringe width. That is denoted by a symbol beta. Beta is a fringe width or bandwidth. From this only most of the formulas will be coming as a problems. Beta equal to lambda d by small d. Beta equal to lambda capital D by small d. See, for both dark as well as bright fringe we are getting the same formula. Lambda d by d. Is it so? What is capital D? Capital D is the distance between the coherent source and the screen. That is capital D. Small d, distance between the two coherent sources. And beta is the fringe width or bandwidth. What is fringe width or bandwidth? Means distance between two successive bright bands or dark bands. See previous year. This blue color, distance between two blue colors, first to two blue colors, or distance between first to two dark color. That is only bandwidth or fringe width. Beta equal to lambda d by d. So as for bright as well as dark fringe width is same. Both bright and dark bands are equally spaced. Both bright and dark bands are equally spaced. And distribution of intensity, I max is proportional to A plus A whole square, that may be 4A square. 2a whole square is 4a square. And for all the bright fringes have the same intensity, I minimum equal to 0. Condition for sustained interference. Two sources producing interference must be coherent. That already we discussed. It must be a coherent source. And coherent source means it will be having same plane of polarization. And two sources must be very close to each other, and the pattern must be observed at a larger distance. That is, small d must be small and capital D must be large. That is another condition. And the source must be monochromatic. What is monochromatic? What is monochromatic light source? Single wavelength, definite wavelength. Monochromatic light is a light having definite wavelength or single wavelength. Otherwise, fringes of different colors will overlap. Two waves must be having same amplitude for better contrast between bright and dark fringes. These are the important conditions for interference. Colors in thin film. We may observe that in rainy season, there will be a color in the water, which is stagnant water on the road. The color film is because of interference. Okay, that is delta equal to 2 mu t cos r. Delta is a path difference equal to 2 into mu. Mu is the refractive index, t is the thickness of the oil film, r is the refraction. And same like that, 2 mu t cos r equal to n plus 1 by 2 lambda. That is for condition for bright band, and this is condition 2 mu t cos r equal to n lambda is the condition for dark band. Polarization. This will be a last topic. And what is polarization? Polarization is a phenomenon of restriction of waves in a particular plane. That is called polarization. Because of polarization only, that is actually best example for polarization, polaroid film. That is a cooling glass. Cooling glass is a polaroid film. And here if E oscillates back and forth in straight line, the wave is said to be linearly polarized. If the direction of E changes irregularly, the wave is unpolarized. And when light passes through a single Polaroid P1, light intensity is reduced to off. And when a second Polaroid P2 is also included at one specific rotation with respect to P1, net transmitted intensity is reduced. So, what is the use of polarization means? It helps to reduce the intensity of the light wave, sunlight. And during solar eclipse and all, we will use, scientists will advise, don't look the sun directly. At the time, we have to use only specialized Polaroid glass only. That Polaroid glass cut the intensity, reduce the intensity. Unpolarized sunlight scattered by the atmosphere or reflected from a medium gets polarized, partially polarized. And this is unpolarized. That is, vibration takes place in all the direction. And vibration takes place only in one direction. This is polarized. So normally you are looking through the sunlight means it will be unpolarized. And using sunglass, we are seeing means then that is the polarized glass. Only one direction vibrations or takes place. Optical activity. Linearly polarized light passing through some substances like sugar solution undergoes a rotation of its direction of polarization proportional to the length of the medium, transverse and concentration of the substance. This effect is called optical activity. And intensity of light I equal to I naught cos square theta. I is the intensity of light after polarization and I naught is the original intensity and theta is the angle between the analyzer and the polarizer. Polarizer means polarizer is the device which used to produce polarized light. Analyzer, it is a device used to analyze whether the light is a polarized light or unpolarized light or partially polarized light. That is the analyzer. And Brewster's law is a continuation of polarization. Tan theta equal to mu. Here also problems will be asked. Tan theta equal to mu. Theta is the angle of polarization. Tangent of the angle of polarization is equal to refractive index. Tangent of the angle of polarization is equal to refractive index. This is called Brewster's law. This is called Brewster's law. And polarization by scattering. Light is scattered when it meets a particle of small size compared with its wavelength. The scattering of sunlight by dust particle is an example of polarization by scattering. And Rayleigh scattering is a scattering of light with the fourth power of wavelength. That is, the scattering is inversely proportional to fourth power of wavelength. And wavelength of light incident on the air molecule of size d, where d is very, very less than lambda. And blue light is scattered more than red. That's why sky appears blue. Actually, in web gear, violet or blue is only shorter wavelength, and red is a longer wavelength. And that's why that is C or larger area, C and sky appears blue. It means blue light is scattered more. Blue or violet, which is having shorter wavelength scattering is more. And mostly that signals and all, red light will be, that is, emergency light will be in red color. Why means red is having longer wavelength, less scattering. So less scattering means more penetration will be there, and red light can travel to longer distance with less amount of scattering. That is why red light will be used for that. Okay. Okay, thank you students. So after a small break, 10 minutes break, we will continue next chapter. Okay, students, welcome back to live session, stream live session. Chapter 11, this is dual nature of radiation and matter. Already we have discussed dual nature, dual role means double role. Electron emission. Thermionic emission, that is the process of emission of electrons when a metal is heated, is known as thermionic emission. The emitted electrons are called thermions, and emitted number of thermions depends on temperature of metal surface. Process of emission of electrons when a metal is heated is known as thermionic emission, and the emitted electrons are called thermions. The thermal electrons is shortly called as thermions. Emitted number of thermions depends on temperature of metal surface. Field emission, the process of emission of free electrons when a strong electric field of the order of 10 power 6 or 10 power 8 volt per meter is applied across the metal surface is called field emission or cold emission, as in spark plug. In petrol engine spark plug will be used. Photoelectric emission. The process of emission of electrons when light of suitable frequency is incident on metal surface is called as photoelectric emission. The process of emission of electron when light of particular frequency is incident on a particular metal surface. That phenomenon is called photoelectric emission, and that effect is called photoelectric effect, and emitted electrons are called photoelectrons, and number of photoelectrons emitted depends on the intensity of the incident light. Number of photoelectrons or photoelectric current depends on intensity of the incident light. Secondary emission, the process of emission of free electrons when highly energetic electron beam is incident on a metal surface is called secondary emission. The process of emission of free electrons when highly energetic electron beam is incident on a metal surface is called secondary emission. The emitted electron is called secondary electrons. Emitted electron is called secondary electrons. Photoelectric effect. The phenomenon of photoelectric emission was discovered by Hertz in 1887. And William Alvax and Philip Lenard investigated the phenomenon of photoelectric emission in detail during 1886 to 1902. Certain metals like zinc, cadmium, magnesium, etc. are responded only to UV light to cause electron emission. That only we said particular frequency only. It will respond to particular frequency. So these metals, zinc, cadmium, magnesium, or respond with the UV light only. Respond means it emits electron, photoelectron. However, some alkali metals such as lithium, sodium, potassium, cesium, rubidium are sensitive or respond with the visible light. Visible light whose wavelength will be in between 4000 Armstrong to 7000 Armstrong. The minimum quantity of energy needed to remove an electron from metal surface is called work function. The minimum quantity of energy needed or required to remove an electron from metal surface, that is called work function. Laws of photoelectric effect. For a given photosensitive material and a frequency of the incident radiation above threshold frequency. What is threshold frequency? Threshold frequency is the minimum frequency required to produce photoelectrons. That is called threshold frequency. For a given photosensitive material and frequency of incident radiation, photoelectric current is directly proportional to intensity of light. That is, if you plot a graph photoelectric current along y-axis and intensity of light along z-axis, then we will get a straight line. That only directly proportional. Okay. This is first laws of photoelectric effect. Second law, for a given photosensitive material and frequency of incident radiation, saturation current is found to be proportional to intensity of radiation, whereas the stopping potential is independent of intensity. Stopping potential is independent of intensity. That is, see the curve? For a different intensity, different photoelectric current. But stopping potential is same. Whatever intensity, stopping potential is same, that is called V naught. Third law, for a given photosensitive material, there exists a certain minimum cutoff frequency, that is called threshold frequency, below which no emission of photoelectron takes place. Whatever intensity of light may be, whatever high intensity of light is falling, if the frequency is less than that threshold frequency, that is called minimum threshold frequency, there will be no emission of photoelectron. And this threshold frequency is different for different metals. For example, cadmium one value, magnesium one value, like that different. Above the threshold frequency, stopping potential or equivalently maximum kinetic energy of the emitted photoelectron increases linearly with the frequency of the incident radiation, but is independent of its intensity. Here this is a graph plotting stopping potential along y-axis and frequency of incident radiation along x-axis. And for a metal A, mu is greater than mu naught. And for metal B, mu is greater than mu naught dash. And mu naught is a cutoff frequency, it is different for different metal. For metal A, this is mu naught, and from metal B, mu naught dash. So this cutoff frequency or threshold frequency, that is different for different metals. Fourth law, maximum kinetic energy of photoelectrons or stopping potential varies linearly with the frequency of incident radiation, but is independent of intensity. Maximum kinetic energy of photoelectron or stopping potential varies linearly with the frequency. See, when frequency is changed, nu1, nu2, nu3, then stopping potential also different. This is one stopping potential, second stopping potential, third stopping potential. For different frequency, different stopping potential. But photoelectric current will be same, constant. And photoelectric emission is an instantaneous process. What is instantaneous process? Immediate time. When your light falls, photoelectric effect will be produced. Photoelectron will be emitted. Suppose light falls in this time, and after a certain time photoelectron emitted. It's not like that. Immediately, when your light falls, photoelectron will be ejected. When your light falls, photoelectric emission occurs. That is the instantaneous process. No delay process. Okay. Einstein's theory of photoelectric effect. Einstein explained photoelectric effect with the help of Planck's quantum theory. When a radiation of frequency nu is incident on a metal surface, it is observed in the form of discrete packets of energy called quanta or photons. A part of energy h nu of the photon is used in removing the electrons from the metal surface, and remaining energy is used in giving kinetic energy to the photoelectron. And Einstein's photoelectric equation is kinetic energy equal to half mv square equal to h nu minus w naught. And this is the Einstein's photoelectric equation. You know Einstein's equation. What is the Einstein's equation? Einstein equation, famous Einstein equation. E equal to mc square. And Einstein got Nobel Prize for not E equal to mc square. He got Nobel Prize for photoelectric emission only. For this equation only he got Nobel Prize, not for E equal to mc square. And here W naught is the work function of the metal. And if nu naught is the threshold frequency, then W naught equal to h into nu naught. In some place we may use W naught, some place phi also will be used. Okay, W naught or phi naught. In many of the problems we may use phi. W naught or phi naught. Okay, that is called work function. And if nu naught is a threshold frequency, then W naught equal to H nu naught. If nu naught is a threshold frequency, then W naught equal to H nu naught, then kinetic energy of mv square equal to H into nu minus nu naught. Of mv square equal to H we have taken out, H into nu minus nu naught. And your experimental observations can be explained on the basis Einstein's photoelectric equation. All the experimental observation explained on this Einstein's photoelectric equation only. Compton shift, Compton effect. We said in different theories of light, no, this theory not able to explain photoelectric effect, this theory not able to explain Compton effect. This is a Compton effect. Actually, this Compton effect is in engineering physics very, very important topic. For engineering students, second semester in engineering physics, in quantum physics, Compton effect is a standard essay type question, 3-page derivation. And that will be a final formula. This is a formula. After 3-page derivation, by applying law of conservation of energy and by applying law of conservation of momentum along the same incident direction, along perpendicular to incident direction, some 3-page derivation will be there. Then students are able to derive del lambda equal to H by m naught c into 1 minus cos phi or cos theta. And what is Compton shift? It is the phenomenon of increase in wavelength of X-ray photon which occurs when these radiations are scattered on striking an electron. Phenomenon of change in wavelength, especially increase in wavelength of X-ray, not UV light, not visible light, X-ray only. Then the difference in wavelength of scattered and incident photon is called Compton shift. That is a del lambda equal to lambda dash minus lambda mostly will be used. Del lambda equal to lambda dash minus lambda. Lambda is the incident wavelength. Lambda dash is the scattered wavelength. We said already increase in wavelength only. So increase in wavelength means lambda dash is greater than lambda. So del lambda equal to lambda dash minus lambda equal to H by m naught c into 1 minus cos phi or cos theta. Here cos theta is the angle of scattering. Actually in our derivation we used to give theta only because phi will be a recoil angle. It's another angle will be there. Okay. Then phi, according to this formula, phi is the angle of scattering or scattering angle and m naught is the rest mass of electron. What is the rest mass of electron? That is electron mass which is at rest. M naught equal to 9.1 into 10 power minus 31 kilogram. This is the rest mass of electron. Dual nature of radiation. Light has dual nature, double role. What is the dual nature? What is the double role? Particle as well as particle nature, another one wave nature. It behaves as a particle in one experiment, other experiment wave nature. If it is particle, light is a particle, forget it is a wave. And if light is a wave, forget it is a particle. That's why we said it is a two sides of a coin. And it manifests itself as a wave in diffraction. Wave nature in diffraction, interference, and polarization. And it shows particle nature in photoelectric effect and Compton effect. Then dual nature of matter, as there is complete equivalence between matter, that is called mass, and radiation, energy, and the principle of symmetry is always obeyed. De Broglie suggested that moving particles like proton, neutron, electron, etc. should be associated with wave known as de Broglie wave. That is, light, we said light is a wave. And According to dual nature, light is a wave, acts as a particle. Light, which is a wave, can act as a particle. Then why particle like electron act as a wave? That is only de Broglie wave. But all the particle is not appear as wave. Only smaller particle like electron only can appear as a wave under certain condition. That only. See, de Broglie suggested that moving particles like protons, neutrons, electrons should be associated with waves. That wave is called de Broglie wave, and their wavelength is called de Broglie wavelength. The de Broglie wavelength of a particle of mass m moving with velocity v is given by lambda equal to h by p or h by mv. H by p or h by mv. Or another formula will be there, equal to h by root of 2m E. E is the kinetic energy. Or also equal to h by root of 2m EV in terms of potential. Okay. And here h is a Planck's constant, p is the momentum, m mass, v velocity, E kinetic energy, E is the charge of the electron, capital V volts. Then de Broglie wavelength of an electron. Lambda equal to h by root of 2m EV. Lambda equal to h by root of 2m EV. Already in previous I have given, no? Lambda equal to h by root of 2m EV. Then substitute the value of h, 6.6 into 10 power minus 34. M, mass of the electron. H equal to 6.626 into 10 power minus 34 joules into second. Mass of the electron, 9.1 into 10 power minus 31 kilogram. And E, what is E? E is the magnitude of charge, 1.6 into 10 power minus 19 coulomb. Then if you substitute this and simplify, you will get 12.3 Armstrong. 1 Armstrong equal to how much? 1 Armstrong equal to how much? 10 power minus 10 meter. If you substitute h value, m value, e value, then we will get 12.3 into 10 power minus 10 meter. That is only Armstrong by root v. So all the things are constant. H is constant, mass of the electron constant, E constant, 2 constant or constant. So simplify all these things. Then we will get 12.3 into 10 power minus 10 meter, and depends upon V only. What is V? V is the applied voltage or applied potential. Therefore, simplify formula, lambda equal to 12.3 Armstrong by V, root V. So, by knowing the value of root V, no need to substitute these things and simplify. Suppose in one formula given, one problem given, that is the electron whose potential is V equal to 10 volts or 100 volts. Find the de Broglie wavelength of an electron. Means electron only, means mass is same 9.1, E 1.6 10 power minus 19 only, H constant only. So no need to simplify this, just remember 12.3 Armstrong formula by root V. V equal to 100, square root of 110, simplify and write. We will do one small problem now. Suppose V equal to 100 volts. Find the de Broglie wavelength lambda. This is a question. Then what is the formula? Our formula, lambda equal to 12.3 Armstrong, that is 10 power minus 10 by root of 100. Root of 100 is 10. So 12.3 by 10. 10 Armstrong. 12.3 by 10 is 1.23 Armstrong. So wavelength of the de Broglie wavelength of the electron for the potential 100 volt is 1.23 Armstrong. Simple problem. Okay. And de Broglie wavelength associated with the particle of momentum p is lambda equal to h by p. Lambda equal to h by p, h by mv, that already we know, and lambda equal to 1.22 by root v nanometer. In terms of nanometer means 1.22 or 1.23. Armstrong means 10 power minus 10. What is nanometer? Nanometer how much? Yes, 1 nanometer equal to 10 power minus 9 meter. 10 power minus 9 meter. So this is in terms of nanometer. Here V is the magnitude of the accelerating potential or applied voltage. And Davison and Germer experiment only proves the existence of de Broglie wave. What is de Broglie wave? That is the electron-like particle is associated with the wave. That wave is called de Broglie wave. Other name of de Broglie wave is matter wave. I will write here. Other name of de Broglie wave is matter wave or pilot wave or pilot wave. This is the other name of de Broglie wave. And the proof of the existence of de Broglie wave is Davison and Germer experiment. And here finally we are getting diffraction pattern will be observed. Okay, electron beam is allowed to fall on the nickel target and galvanometer adjustment will be there. Finally we are getting diffraction pattern. Diffraction is the experiment which proves wave nature. Okay, so as diffraction patterns are observed, we can say it is a wave. Electron is moved in the form of wave. Electron, we said it is a particle, it's moved in the form of wave. So electron which is acting in the wave nature, that is called de Broglie wave or matter wave or pilot wave. Okay. And main important application of matter waves or de Broglie waves or pilot wave is electron microscope. What is electron microscope? What is the difference between electron microscope and compound microscope or normal optical microscope? Microscope, we know. What is microscope? It is an optical instrument. Which? Microscope is the optical instrument. Which? Microorganism. Smaller object appears as a magnified one. That is the microscope. That is a magnifying lens may convert 10 times or 100 times. Normal magnifying lens is a simple microscope. Compound microscope in biology lab we are using. So see the microbes and all, slides and all. That is the compound microscope. And electron microscope is, that is for example, compound microscope, its magnification will be 1000 times. For compound microscope it will be 10 power 3 times, 1000 times it will be magnified. But electron microscope may magnify 10 power 6 times, million times. That is the electron microscope. And electron microscope, like optical microscope, is an instrument principally used in the research laboratory for magnifying small objects. Even electrons, protons, that particle and all can be seen through electron microscope only. The wave nature of moving electron is the basis for the electron microscope. The resolving power of a microscope is the least distance between 2 points which can be distinguished. Already I said. That is the 2 points, closer object appears as a separable one. That is the resolving power. And resolving power of microscope is limited by wavelength. Take a white color. That is, resolving power depends upon the wavelength. Resolving power is inversely proportional to wavelength. Okay. And in optical microscope, visible light is used. Is it so? Visible light is used to illuminate the object, and the highest magnification obtained with the best optical microscope is 2000 times. I said approximately 2000 times. Since the wavelength of X-ray is smaller than visible light. Actually compare with visible light, before visible light, UV light, before UV light, X-rays. So X-rays wavelength is shorter. And if wavelength is shorter, what about resolving power? If wavelength is decreases, resolving power increases or decreases as per this formula? Resolving power is inversely proportional to wavelength, and if wavelength is decreased, resolving power is increased. So, instead of ordinary light, we can use X-rays. But X-rays cannot be deviated. Like in convex lens, convergence takes place. Concave lens, diverging of beam takes place. Like that, we can't deviate the X-ray. So, wavelength of the de Broglie wavelength of the electron, that is the de Broglie wavelength, that is comparably equal to the wavelength of the X-ray. Wavelength of the electron or de Broglie wavelength is equal to wavelength of X-ray. So, instead of X-ray, we can use electron beam. Okay. So, instead of light in optical microscope, we are using electron beam. That is only this setup. See? Actually, this is optical microscope, normal optical microscope, this one. This is, wait, I'll change the color. This is optical microscope. Light source, slit, condensing lens. Your lens will be try to make a straight line path, collimating the light. And object, it falls on an object, and objective lens converge to a particular point as the intermediate image, and then projector lens or eyepiece again magnified as a final image. That's a virtual image. Okay, this is only 10 power 3 times. Same thing here, electron microscope. Electron microscope, instead of light, what's using? Electron gun, which produces electron beam. And here, how the beam will be converged or diverged like condensing lens means there will be a magnetic field will be produced. That only we are calling magnetic condensing lens. Okay, this magnetic condensing lens only will converge the beam or diverge the beam or make parallel to the beam, and finally we are obtaining the final image. That final image will be approximately 10 power 6 times of the original object. Okay, this is only a electron microscope. This is electron microscope. And electron microscope is a basic for atomic physics. And advanced form of electron microscope is SEM, scanning electron microscope. SEM. This is a scanning electron microscope. This, for my research, I use this SEM, scanning electron microscope, in Anna University mechanical department. The rate of SEM there they said is, they showed the cost of that is 1 crore. Rate of 1 SEM. For what purpose we use this? SEM, and another one is TEM. TEM is a tunneling electron microscope. This is all advanced form of electron microscope. What purpose we are using these things means this also will be in crore only. And what purpose we are using these two, SEM and TEM and all means this is to find the dimension of a nanoparticle. Nanocrystals. What's the nanoparticle means? 10 power minus 9 meter. I grown some crystals. That crystal I converted to nanoparticle, and size of the crystal I estimated using SEM. And I got the result as that value will be 40 nanometer to 60 nanometer. This I found using SEM only. What is SEM? SEM is a scanning electron microscope. Engineering students are studying both SEM, scanning electron microscope, TEM, tunneling electron microscope, and STEM, another one STEM. Like that, lot of things are there. Okay, so this chapter over. Let's move to next chapter, chapter 12, atoms. 12th chapter, atoms. Atoms or atomic physics. So just like light, atoms also explained by different theory. As we have discussed now, light is explained by corpuscle theory. It was able to explain light undergoes reflection, refraction. Next, what's the second theory? Huygens Huygens wave theory. And next theory,
Maxwell.
Maxwell's electromagnetic theory. Next one, Planck's quantum theory. Is it so? Planck's quantum theory. And last one, dual theory by de Broglie. Like that, atoms also explained by different theory. First one, Dalton's atomic theory. It was postulated by John Dalton in 1803. According to him, all elements are composed of invisible particle called atoms. Invisible and indivisible particle called atoms. And atoms of same element are exactly alike. All are similar. Atoms of different elements are not alike. For example, oxygen means all the oxygens are same. Nitrogen, all the nitrogen are same. But oxygen and nitrogen are not same. That was said by Dalton. Compounds are formed by joining atoms of two or more elements. How compounds are formed according to him is by joining two atoms or two or more elements of the atoms. This is John Dalton's atomic theory. Okay. Next theory, Thomson's atomic theory. Thomson's atomic model, postulated by J.J. Thomson. According to him, atom consists of positively charged protons and negatively charged electrons. J.J. Thomson only discovered electrons. Atom consists of positively charged protons and negatively charged electron. And an atom could be divided into its constituent elementary particles, and atom is neutral.
Discovered electrons.
J.J. Thomson only discovered electrons. And during this time and all, they don't know about nucleus or don't know about neutrons. Neutrons are discovered only at the time of nuclei only. Okay. So atom consists of positively charged protons, something inside that is a positive charged one. That positive charge is maybe a proton, which was discovered by Goldstein. Goldstein only discovered proton, and negative charged electron. And atom could be divided into constituent elementary particle. That is, all the elementary particles are made up of atoms only. And atom is neutral. Proton is positive charge and electrons are negative charge. So atom is neutral, neutrally charged. Next atom model, Rutherford's atomic model, which was postulated in 1909. He showed that atom has a nucleus. He only said something is inside highly dense core of an atom. That is, using alpha particle scattering, he observed that there will be a, suppose this is an atom, and when alpha rays is allowed to fall on this, at particular region, small denser region, more amount of alpha particle will be reflected back. And here and all, there will be a no change. So something is present inside the dense core. The dense core of an atom that only found by, discovered as nucleus. He only showed that atom contains some dense particle is present, dense region is present, that is called a nucleus. And inside the nucleus, protons and neutrons are present. Not only protons, neutrons, which is a neutrally charged particle, also present inside, was said by Rutherford. Outside the nucleus are electrons. Electrons are revolving around the nucleus. Discovered that all the positive charges are concentrated at the center of atoms called molecules. And by shooting alpha particle, alpha ray, through a gold sheet, he used a gold thin foil sheet and counting the number of particles that went through. And based on that only he found that there will be a more vacuum space region, here and all vacuum space, here vacuum space, and here only denser regions are there. Okay. And he said that the electron orbit around the nucleus is like the planet orbit around the sun, but could not explain why the electrons were falling into the nucleus, because electrons are negative charge and nucleus or neutrons, the nucleus contain protons and neutrons, that is positive charge. So electrons and protons should attract. Nucleus charge is positive, electron charge is negative. So it should fall and electrons should be attracted by the nuclei, but it's not attracted. Why? That's not explained by Rutherford. That's one of the drawback. distance of closest approach R naught equal to 1 by 4 pi epsilon naught into 2z e square by ek. In 2 to 3 days back in atoms, in problem solving session, there is a distance of closest approach R naught, depends upon what factor, whether it depends upon mass m, like that some question may be asked. R naught is the distance of the closest approach. R naught depends upon initial kinetic energy Ek of the alpha particle. And impact parameter, the scattering angle theta of the alpha particle and impact parameter B are related as B equal to z e square cot theta by 2 by 4 pi epsilon naught Ek. Ek is the kinetic energy, Z is the proton number or atomic number, E is the magnitude of charge, and theta is the angle, epsilon naught is the permittivity of free space or vacuum. And smaller the impact parameter, larger the scattering angle. Theta is the angle of scattering. If impact parameter is small, then scattering angle will be more. Or if scattering angle is more, impact parameter will be small. Okay. Next, Bohr's atomic model. Bohr's atomic model. This Bohr's atomic model was postulated by Niels Bohr in 1913. That is, the electrons in an atom are revolving in a certain fixed orbit. Previous person and all, electrons can travel or revolving in any orbit. But he only said fixed orbit, that is called stationary orbit, for which the angular momentum of the electron is an integral multiple of h by 2 pi. Angular momentum of an electron is an integral multiple of h by 2 pi, and here h is a Planck's constant. That is, L equal to integral multiple of h by 2 pi means n into h by 2 pi, or n into h cross. H cross equal to h by 2 pi. This is the Bohr's postulate. Angular momentum is the integral multiple of h by 2 pi as n h by 2 pi. And the electrons in the stationary orbit do not radiate energy. That's why we said stationary orbit. It does not radiate energy. And an atom may absorb or emit discrete energy of photon only when one of the electron of atom jump from lower orbit to higher orbit or from higher to lower orbit. Okay. That is, atom may absorb or emit energy by observing energy by when it jumps from lower to higher orbit or higher to lower orbit. That is, it moves from lower to higher orbit by observing some amount of energy. And when it moves from higher orbit to lower orbit, it emits some amount of energy. And that energy is h nu equal to En minus Em. What is Em? Em is the electron energy having lower energy state, and En is the higher energy state or initial state of energy. And stable orbits do not emit radiation by acceleration. Whether if it's accelerated or not accelerated, it will be accelerated and it will not emit radiation. That's why it's called stable orbit. And electrons revolve around the nucleus in definite orbits, and radius of nth orbit is Rn is proportional to n square by z. Radius of the nth orbit is Rn equal to n square by z. N is the quantum number, value 1, 2, 3, etc. as n equal to 1 is a ground state and z is the atomic number. Wave model is based on wave mechanics. Propose that electrons do not move in a definite orbit and that the location of electron is based on how much energy each electron contains. Propose that electrons do not move in a definite orbit and that the location of electron is based on how much energy each electron contains. Based on that only, location of electron is present. And quantum numbers are the numbers required to completely specify the state of electron. Quantum numbers are the numbers required to completely specify the states of electron. There's a different quantum numbers are, that is in the presence of strong magnetic field, principal quantum number. can have value 1, 2, up to infinity. Orbital quantum number denoted by symbol L. It can have value 0, 1, 2, 3 up to n minus 1. Magnetic quantum number is denoted by symbol M suffix L, which can have value minus L to plus L. And magnetic spin quantum number MS, which have value only 2 value, plus or minus 1 by 2. That is a spin quantum number. So by knowing principal quantum number, it's possible to find all the quantum number. Principal quantum number n depends upon n only 0, 1, 2 up to n minus 1. And depends upon L only magnetic quantum number as plus or minus L. And magnetic quantum number plus or minus 1 by 2. The minimum accelerating potential, which provides the sufficient energy for an electron to make a transition from the innermost orbit to any one of the outer orbit, is called excitation potential. Minimum accelerating potential provides a sufficient energy for an electron to make a transition from innermost orbit, that only we are calling ground state. For that only n equal to 1. Ground state means n equal to 1. We will do some problems based on this. And to any one of the outer orbit, that we are calling excited state. N equal to 2, 3, 4, etc. is the excited state. N equal to 2 means first excited state. Even in atoms, in previous some days back, we worked out problems in problem solving session. That is, what is the excitation potential from ground state to first excited state? Ground state means n equal to 1. First excited state n equal to 2. Second excited state n equal to 3. N equal to 4 is third excited state. And the minimum accelerating potential, which provides a sufficient energy for an electron just to remove it from the atom, is called ionization potential. The minimum accelerating potential, which provides the sufficient energy for an electron just to remove it from the atom, that is called ionization potential. Excitation potential and ionization potential are different. When an electron makes a transition from n2th orbit to n1th orbit, n2 is higher orbit to lower orbit, then E2 and E1 are their energies, then E2 minus E1 equal to h nu equal to 1 by 2. These are not from Bohr atom model, it's a derived one. Z square e power 4 m by 4 pi epsilon naught whole square h cross square into 1 by n1 square minus 1 by n2 square. And h cross square equal to h by 2 pi, and keep this, all these things are constant, keep as r. R equal to e square e power 4 m by 8 epsilon naught square h power 3 as r. That is called Rydberg constant. If you substitute, then frequency nu equal to rc into z square into 1 by n1 square minus 1 by n2 square. Simplified formula. And in there, mostly wavelength will be there. Nu equal to c by lambda. If nu equal to c by lambda, if you substitute, nu equal to c by lambda. If you substitute there, then here c by lambda, if you put cc getting cancelled, then 1 by lambda equal to r into z square into 1 by n1 square minus 1 by n2 square. From that only different spectral series of hydrogen atom, that is Lyman series, Balmer series, that and all will be discussed. That only this. Depending on the orbit in which transition occurs from higher orbits, there are different spectral series are there. That is Lyman series. What is Lyman series? When higher orbit, any of the second orbit to third orbit, or any of the higher orbit to first orbit, if an electron jumps from any of the higher orbit to first orbit, then that is Lyman series. It falls under ultraviolet region. Balmer series. If an electron jumps from any of the higher orbit to second orbit, then it is in visible region. So in this formula, nu equal to r I'll write there. That is 1 by lambda equal to R into 1 by n1 square minus 1 by n2 square. Okay, this is the formula, and in there, if n1 equal to 1 and n2 equal to 2, 3, etc., then it is Lyman series. And if n1 equal to 2, if n1 equal to 2 and n2 equal to 3, 4, then that is Balmer series, then that is visible region spectrum. If an electron jumps from any of the third orbit or fourth orbit or any of the higher orbit to second orbit, then light energy emitted will be invisible light. We can see. Paschen series. If the electron jumps from any of the fourth to fifth like higher orbit to third orbit, then it is near infrared region. Bracket series, any of the fifth, sixth to fourth orbit, mid infrared region. Fund series, any of the higher orbit from 6th to 7th etc. to 5th orbit. That is only n1 equal to 5 and n2 equal to 6, 7, then for infrared radiation. So in this also we will work out more problems. Okay, Lyman series, Balmer series, Paschen series, bracket series, Fund series. Okay. Comparative study of spectral series. As the order of spectral series increases, the wavelength of lines increase. Order of spectral series increase, wavelength of line increase. That is, lambda fund is greater than lambda bracket is greater than lambda Paschen is greater than lambda Balmer is greater than lambda Lyman. Lyman is the first, Balmer second, Paschen third, bracket is 4, fund is 5 in that order, formula order. And here spectral series, order of spectral series increase, the wavelength of the lines increase. Therefore, lambda fund will be more and lambda Lyman will be least. And the maximum number of spectral lines obtained due to transition of electrons present in nth orbit is n equal to n into n minus 1 by 2. And frequency nu equal to c by lambda. Then for lambda maximum, frequency is maximum. For lambda minimum, frequency is minimum. And energy E equal to hc by lambda, that is equal to h nu. This is a basic formula we know. Some of the Bohr's formula. That is the radius of nth orbit. Rn equal to, this is the formula, Rn equal to 0.529 n square by z. That is substituting 4 pi epsilon naught value, h square value, m value, and simplified formula, Rn equal to 0.529 n square by z in Armstrong. Armstrong means 10 power minus 10 meter. And velocity of electron in the nth orbit, Vn equal to 1 by 4 pi epsilon naught into 2 pi z e square by nh, and this simplification we are getting as 2.2 into 10 power 6 by n z. That is, if you feel difficult to remember this formula, at least remember this formula. Rn equal to 0.529 n square by z Armstrong, and Vn equal to 2.2 into 10 power 6 z by n. Because mostly in problem, z value will be given, n value will be given. So you can find the velocity. Same way kinetic energy. Kinetic energy nth orbit equal to formula 13.6 z square by n square eV. Kinetic energy equal to 13.6 z square by n square eV. What is Z? Z is the atomic number. Here element will be given. Hydrogen means 1, helium 2, like that. Carbon 6. So based on the element, Z value will be substituted, and n is the quantum number. And here this formula will be derived in the form of EV, not in joules, EV form. Already converted to EV. Same way, potential energy of electron in nth orbit, Un equal to minus 27.2 Z square by n square EV. And total energy En equal to minus 13.6 Z square by n square EV. That is, in problem solving session, there will be a question will be asked, what is the ratio of the kinetic energy and total energy of an electron in Bohr's atom model? So En formula minus 13.6 z square by n square EV, and Ek formula plus 13.6 z square by n square EV. So based on that, 1 is to minus 1 like that. That will be option, correct option like that we have given in problem solving session. And the frequency of electron in nth orbit 6.62 into 10 power 15 z square by n cube. This is the derived formula, and simplified formula, that is by substituting 4 value, pi value, E value, h cube value, epsilon naught value. This is the formula. 6.62 into 10 power 15 z square by n cube. Okay. Next, wavelength of radiation. This only we are applying for Lyman series, Balmer series, bracket series, Fund series there and all. That is 1 by lambda equal to R into Z square into 1 by N1 square minus 1 by N2 square. Here N1 equal to 1 and N2 equal to 2, 3, 4 for Lyman series. Like that we have discussed. And here R is the Rydberg constant value 1 by 4 pi epsilon naught whole square 2 pi square m e power 4 c h cube. Value will be 1.09 into 10 power 7 per meter. That's the value of Rydberg constant. So this formula only we are applying for spectral series of the hydrogen atom. And ionization energy. Minus 13, the ionization energy is 13.6 Z square by N square EV. Ionization potential 13.6 Z square by N square volt. That is, energy and volt are just related by a formula. As E equal to EV and EV equal to that is, if you cancel E, then that gives V. That is only potential. So energy can be converted into volt by reducing E divided by electron charge. So ionization energy is in EV and ionization potential is in volt. Suppose energy is given 13.6 EV, then ionization potential is V equal to 13.6 volts. Next, in quantum mechanics, the energies of the system are discrete or quantized. Energy of a particle of mass m is confined to a box of length L, can have discrete values of energy En equal to n square h square by 8m L square. Here n equal to 1, 2, 3. Actually, this is famous Schrodinger wave equation. Quantum mechanics is a basic for quantum mechanics, that is a Schrodinger wave equation. There one of the application, n square h square by 8m L square. This is the Schrodinger wave equation. Where is the color? Schrodinger wave equation. That is, without Newton's law, no mechanics. Like that, without Schrodinger wave equation, no quantum mechanics. Schrodinger wave equation is a very important wave equation for quantum mechanics. And this is the derivation, one of the application for Schrodinger wave equation. And excitation energy we have discussed is the energy required by electron of atom to jump from its ground state to any one of the excited state. And ionization energy, energy required to remove an electron from atom, that is energy required to take an electron from its ground state to outermost orbit. Excitation potential is a voltage, exciting potential to bombard electron, so to exciting the target atom by raising one of its electrons from inner to outer orbit. Ionization potential is the exciting potential which gives two bombarding electron the sufficient